Welcome. In this video, I'll be talking about electricity, how it works, and the principles guiding it. To start with, what is electricity? Simply put, this is a form of energy that we use to power lights or any electrical devices. Examples of electricity is energy used to power our bulbs, our fans, our televisions. That is electricity. But a quick one, how does electricity work? Electricity is the movement of electric charges from one point to another, which is from a point A to a point B. So it simply means electricity has to move from these points to these points. That is how electricity works. And in that movement, they carry electric charges. Guys, don't be alarmed. Now let me talk about what electric charges is. Electric charge are also known as currents. I know you'll be hearing about current. So electric charge is the same thing as current. So it's either I'm saying electric charge or I'm saying current. So we can say electricity is a movement of currents from one point to another. These currents are made up of positive and negative currents. So this current, guys, are movement of positive and negative electrical particles in a circuit. Now, what is a circuit? A circuit is a closed circle that electric charges can travel in, whereby a source of electricity such as battery provides electrical energy in that circuit. For example, we have a railway for a train. So also a circuit is what a current has to travel in a circular form, in a continuous form, to actually give you a result or an outcome. To actually explain this, if you look at this diagram I have here on my right hand side, you are going to see how these particles, these currents, move from one point to the other. Now you can see my battery, where you have the positive and the negative terminal. The positive terminal have the longer arrow and the negative have the shorter one. And you can see from that diagram that the negative is flowing through the bulb. Yes, this one that is shining is my bulb. It's flowing through the bulb, then back to my switch. My switch is to cut that circuit or allow it to flow. So when I put my switch on, you can see it is flowing back to the battery. That is what electricity is all about. Now let us bring all these things together and just say it in one simple sentence. So I will say electricity is the movement of currents that are positive charge and negative charge in an electrical circuit. Now that is what electricity is all about. Since everything we are doing as humans are guided by principles, you agree with me that electricity too, that movement, has to be guided by principles. Now let me just state a common principle that everybody needs to adhere to. That is the law of gravity, that says anything that goes up must come down. So also electricity has its own laws that are guiding it. The law on electricity was discovered by George Ohms in the year 1827. No wonder it is known as the Ohm's law. Now what does Ohm's law state? The law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all its physical conditions and temperatures remain constant. It is mathematically rendered as V, the voltage, is equal to the current and the resistance. That is I stands for current and arrow stand for resistance. That is a big grammar, guys. Now let's come on. Let us explain this law with a very simple illustration. And how are we going to do this? We are going to use a car and a driver and explain how this law actually key into the movement of electric currents in an electrical circuit. We understand that for a car to move, it needs to be able to have petrols, tires, engines, and so many things that enables a car to move. Also, there are many things needed for currents or electric charge to move from a point A to a point B in another circuit. And things that they need are voltage, resistance, and conductor. Now, have we seen the part a vehicle needs to move and the part that current needs to move? Now, for a car to first move, it needs tires. Also, guys, for a current to move through a circuit, it needs a conductor. And what is a conductor? A conductor is described as a material that allows the free flow of current through them. Examples of a conductor are wires that either be copper, silver, or aluminum. So these are conductors, and you can see them around you, guys. If you look into your house, you could see copper wires. If you look in your street, you see aluminum wires. These are conductors that allow current to move from one point to another. Now let's go to the second one. If a driver is in a vehicle, he's going to press on the acceleration pedal so that the vehicle will move. So also, for the current to flow through that conductor, it needs the voltage. And what does the voltage do? The voltage provides pressure to push the current through a circuit. So you can see that voltage is like that acceleration pedal that the driver will press down for the vehicle to move. So when the voltage is present in an electrical circuit, definitely it's going to push the current to flow through that conductor easily. Now, guys, if a vehicle is moving, no doubt there'll be a time that the vehicle will stop. So also, electric current is moving through a conductor with the aid of a voltage. There is a time for that flow to stop, and that is when the resistance comes in. So what does the resistance do? The resistance restricts, block, disturb, distract the flow of electric current through a conductor. And for us to better illustrate how a resistance works, let us use a battery and our plug. Normally, if you touch our plug that has light, if you touch the wire, it's going to shock you. But if you touch a battery, if you connect something to a battery and you touch it, it will not shock you. So that battery has very, very high resistance. So the flow of resistance in that circuit is very high. So you will not receive any electric shock. But when you touch our plug or any electrical component that is plugged into an electric source, you are going to receive a shock because the resistance is very, very low. That means the current flowing at that point is actually flowing on a very high speed. That is what a resistance does. So no doubt, I believe this video have helped you to understand all that you need to know about electricity, its flow, and the law guiding it. Now for a quick recap, guys, Remember we said electricity is the movement of current from one point to another within an electric circuit. And then we talk about a law that guides electricity, and that law is the Ohm's law. And the Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant. And we have used a moving car and a driver to explain that a conductor is needed for a current to flow through, just as you need your tires for your vehicle to move. Also, we talked about voltage, that just as the acceleration pedal in your car, the voltage gives pressure for that current to flow easily through that conductor. And finally, every vehicle at a particular point in time needs to stop. So the resistance do that job in any electrical circuit, deterring the free flow of electric current through that circuit, stopping it, restricting it. And just as I have explained why a battery will not shock you, and why your plug, your bulb, your TV, your iron, or anything connected to a power source will shock you, because one has very high resistance while the other one have very low resistance. So no doubt, if this video have helped you, please like, subscribe, and share this very video to your friends. So sit back and relax as I will be talking more about wires, conductor in my very next video. Hope to see you in that very next video.